would like to welcome Dr. Cik Khairil. Oh, sorry, Associate Professor Dr. Cik Khairil here.
Mm,
Thank you.
All right.
okay. Okay. All right. Assalamualaikum and welcome to Dynamics ECS 429. We are now in week 6 of our lecture class, and today is 16th November 2021 and it's already 3:07 p.m. Okay, so let's first recap of what we have learned last week. Okay, so in last week we did topic 2, which is on kinetics of particles. However, what we did is we focus on using Newton's second law. Okay. All right. And if you remember, do you remember the formula for Newton's second law? What is it?
F equals to MA.
Okay, F equals to MA. And then what we learn is there are two different types of methods that we want to do solving kinetics of particles. Can you see my screen, guys?
Yes.
Okay, so
Yes, we do.
basically, okay, good. So basically, we have the rectangular coordinate system.
And then
Okay. Yes, good. We have the rectangular coordinate system and then we have the non-rectangular coordinate system. Okay. So basically, when you get a question in dynamics that is related to kinetics, and again, let me ask you again, how do you know the question is kinetics or kinematics? How do you know it's kinetics? What is the clue?
That's what the
Yes.
force.
Yes, because there are forces involved. Okay. So once you get a question, you read, oh, this is a kinetic question because there are forces acting on the body is involved. You have to decide first which type of coordinate system you want to use. Is it the rectangular coordinate system or the non-rectangular coordinate system? And once you have decided based on the question, then only you can solve the problem. So this one we have already done last week. Okay. All right, we have learned about this last week. And then for the non-rectangular coordinate system, we also have learned. And for the non-rectangular coordinate system, there are two types, which is what?
Normal and tangential, radial and transverse.
Yes, normal and tangential and
Rad
radial and
transverse.
transverse. Okay, and the symbol for normal is N, tangential T, radial is R, and transverse is theta.
Okay.
Okay. Okay, good. So basically, what you need to do is you need to choose which is the best coordinate system to solve the problem. So if the rectangular coordinate system, it means you have to solve it using the x and y components. Remember? So you will have summation forces equals to MAX and then summation forces equals to MAY. All right.
M-A-Y.
So it's something like you have a particle like that, and then you need to resolve it according to components. Okay. So Fx and then Fy. Same with normal and tangential. If you remember that we have gone through this one, you have normal and tangential. So you have one the tangential must be tangent to the path. Normal, how do you determine the normal? It must be what is the clue?
Perpendicular.
Yes,
Perpendicular.
perpendicular. Okay, and it must, the normal direction must be in the concave direction. So if the for the tangent, this will be MAT and this will be
And
MAN. Yeah, so it's similar. So you do summation forces, MAT, and then summation forces, MAN. And then you remember how to calculate AT. Okay, we're just doing a recap before we begin our next topic. What is AT? AT is the derivative time of the velocity, isn't it? Is dv over dt. And what is AN? Do you remember what is the formula for AN? Guys, what is it? Do you remember? Okay, who can answer me? V squared over rho. Okay, remember? Okay, it's okay. Now, again, if you do for radial and transverse, it'll be the same thing, R, and then this will be transverse theta. So it'll be the same method, okay? All right. And then you have the formula for AR, and then you have the formula for, this is the A, yeah? We have the formula for the acceleration for the radial, and you have the formula for acceleration for theta. Do you remember the formula? What is it?
Acceleration.
Yes.
Untuk radial.
Yes. For
Uh,
radio. What is it?
R also ada titik dua kat atas tolak.
Yes. R what? R double dot.
R double dot.
And then?
Second derivative.
And then?
Minus R theta single dot.
Okay.
Squared.
Squared. Yes. Don't forget the square. And then A theta. What is it?
R theta double dot.
R theta. Sorry. R. Okay. Let me. Okay. R theta double dot. And
minus
then?
2R dot theta dot.
Okay, all right. So basically, this is what we this is on kinetics of particle using the Newton's second law. Okay, so it's not that difficult. Once you identify what is the best coordinate system to use, you must draw the correct free body diagram. And once you draw the correct free body diagram, you must also draw another diagram. Do you remember what is the other diagram? There are two diagrams.
Free
Yes?
body diagrams dengan kinetic diagram.
Yes. So you have to draw the free body diagram and kinetic diagram. And once you draw these two, then you can solve the problems using the equations. Okay, that is good. Okay, so that is what we have learned. So for today's class, okay, let's open the lesson plan. Okay. All right. So the lesson plan you can open through Evans. So if you all have the Evans system, or you can also open through UFuture. Okay. You can also open through UFuture. So if I open through Evans here, I have uploaded also the lesson plan here. You can either way, both places we have the information shared for you. Okay, whatever convenient for you. So now we are in week 6. So we're gonna do kinetics of particles. However, what we're gonna do today, class, is we're gonna focus on work and energy. So what is the learning outcome for today's class? We want to be able to define what is the work of a force. You should be able to solve motion of a particle using method of work and energy, and you should be able to solve motion of particles using method of impulse and momentum. Okay, so for today's class, what we will do is we will try to solve the problem using work and energy first today, and then we will do some examples, and then hopefully we can go to method of impulse. So this is our our learning outcome for today's class. So by this week you'll be given assignment 1, and then it will consist of topic 1 until 2. And then what we will do is we will give you almost like a week to complete the questions, and then you can return back the assignment after you come back from the semester break. Okay, so this is what have been discussed with what we have discussed to give, okay, for you. All right, so now okay, are you ready? Okay, and then at the same okay, good. And just hold on. Okay, and then at the same time, also you can open your notes for kinetic of particles for week 6. We have given you the lecture notes. So the lecture notes is already provided for you. So these are the lecture notes. It has already included what is the learning outcome. Okay, so these are the lecture notes. Okay, and then you can access UFuture to look at all the videos. So you just click here and you will go directly to UFuture, and in UFuture there are a lot of numbers of different videos that you can look related to this topic. Okay, and then we also have one video that is already been suggested for you, so you just can already click the video, and then you can see the video that has, if you click, I have to, sorry, press next, I think, but the video has already been provided for you, so you can just look at the video. Okay, all right, let me go back to, okay, so this is the video that we have provided. This video lecturer dynamics provided for you. Okay, and this is based on our lecture notes for week 6. Okay, so these are extra things that you can do, take your time to do. Okay, and then we also have provided tutorial questions that you can do, and these are the tutorial questions that you can do that is related on the topic. Okay, so I need to remind you every week about this. So these are the things that you can do. Okay, all right, now we will begin our class on the topic. Okay,
Yes,
all right,
madam. We
okay,
are
are you
ready.
ready? Okay.
Yes, madam.
Okay, all right. So usually for my class, I prefer students to write the notes. Okay, write the notes, and at the same time, there's already provided a hand notes for you for extra for studying. Okay, all right. So we're here in topic 2, which is on. We're still in topic kinetics of particles. Okay, it means we're still solving problems for that related to kinetics that involve forces of the body. But however, for today's class, what we're going to do is we're going to focus on work and energy. So basically, for the next topic, for week 6, which we are in week 6, what we need to cover, there are two methods, two principles actually that you need to be covered. I want you to get the overall picture first, so that you get a clear picture what is the content involved. Okay, so for the kinetics of particles, for week 6 topic 2. Okay, please mind that sound. Okay, okay, we have two principles that you will need to learn. Okay, which is principle of work and energy, and the other one is principle of linear impulse and momentum. Okay, all right, just give me a second. Hold on. Okay. Okay, abaikan iklan sebentar tu. Okay, alright, biasalah tu kan, you all kan. Okay, now so basically there are two types of principle that we need to learn. Is my screen on back again, and can you hear me?
Yes, yes.
Yes,
Yes,
madam.
Okay,
madam.
all right. Okay, so there are two types of principle that you need to learn. One is principle of work energy, and one is principle of linear impulse and momentum. Okay, so basically, what I want to highlight, what is the major difference between these two principles? Okay, so the major difference in these two principles is basically, if you are dealing with principle of work energy, basically your main outcome that you want to solve is you want to solve problems that is related to force, velocity, and displacement. Okay, and then for principle of linear impulse or momentum, the main thing that you want to solve is involve force, velocity, and time. Okay, can you see what is the difference between these two principles?
Displacement and time.
Yes, okay. So it's very simple. In subject dynamics, the key thing for you to survive, to understand, is basically you need to understand what is the outcome from what is the output using that method, that principle, and what is it you want to solve. Because if you don't understand the difference between the each principle, or you don't know what is the output of the results, then when you get a question during the exam, you don't know where to begin, which method you want to use, because during the test, exams, or what you call assignments or tasks given to you, sometimes they don't tell you which is the preferred method. You will need to actually decide which is the best method to solve the problem. So if the question is calculate the time required, which method would you choose?
Time
Can some
required, linear impulse and momentum.
Yes. When they ask you what is the time required, of course you need to use linear impulse or momentum. And then if you know what is the principle involved in that, what is the formula involved in that, regardless the question is very difficult, you are able to solve it because you already know what is the correct method. Okay. All right. So for today's class, we will start and begin with principle of work and energy, and then only we will do principle of linear impulse and momentum. Okay. All right. So am I going too fast? Are you okay?
Okay,
Okay, madam.
Okay, so now let's do principle of work and energy first. So first, I like to explain the fundamental concept first about it. So once you understand the fundamental concept, then when you get a question, you will not make mistakes in drawing the free body diagram and come up with the correct equations involved. The concept, the fundamental is the most crucial part in understanding principle of work energy, okay? So now we are doing principle of work and energy. Okay, principle of work and energy. Okay, now so when I say the principle of work energy, it is what it means is the work done by the sum of all the forces. Is the work done by sum of all the forces acting on the particle. So what we need is we need the work that is done by all the forces that is acting on the particle, and this will be equal to the kinetic energy of the particle. Okay, so that is the principle of work and energy. Okay, all right. So if you understand that, okay, let me just write a little bit down so that you keep note what it is. Okay, so principle work of energy is the work, okay, done. Okay, this is all already written in your lecture notes also, which you can refer to. Is the work done by the sum of all forces, okay, acting on the particle. Okay, equals to what, guys? If you remember what I said just now, are you focused? Equals to what? Equals to?
kinetic energy.
Okay, but what? It is correct.
Of the
It
particle.
is equal of the kinetic energy, but it's equal to the change. The key word here is the change. Okay, equals to the change in the kinetic energy. Okay, equals to the change in kinetic energy of the particle. Okay, that is the keywords. Okay. All right. Now let's think about some of the applications or examples that is involved in principle of work energy. Okay. One example that I can give you is this example, and I would like you to understand it. Okay. All right. So we have an inclined slope like this, and this inclined slope, of course, it has an angle theta, and on this inclined slope we have a cart. You know, a cart, some kind of cart that carry things, and then this cart has a thing, a pulling thing. Something is pulling it. And then it has a force, okay, a tension force pulling. Okay, so assume you have this cart. Okay, so what you need to do, we have to first, what we need to do is we need to put in all the forces that is involved in this cart. Okay, so if you look at this cart, what are the other types of forces that is involved? Can you name some? Weight, yes. So when you want to draw the weight, is it perpendicular to the plane or is it vertically downwards?
Vertically downwards.
Okay, vertically downwards. This is important, eh? Okay. All right, please mind my drawing because it's not sorry. It's not I don't have a ruler, but I'm sure you will draw it straight right at the bottom. So you have a weight, and what other forces is involved?
Normal force.
Okay, the normal force. Okay. So the normal force, yes, is perpendicular. Good. Okay. All right. So So let's say this is theta. So this angle is a little bit different. Let's say is theta pi. Okay. All right. So first of all, what you need to do is you need to identify what are all the forces that is acting on the cart. Okay. So what is the constant force of the towing force of the cart T? What is the force of the T? Hold on, let me rub this. Okay. What is the force that you know? What is the towing force of the T? It will be what? T? What do you think, guys? Okay, all right. I think I have explained to you last week about this, but it seems that nobody is answering. Okay, but maybe I should give you a more detailed explanation to make you understand better. So maybe I can uh, um, maybe I can explain it in a different way. So I will put hold on this part because actually I expect to by now you will be able to tell me what is the force of T and what is the force of W in the direction of the cart going up the hill, up this hill. But it's okay. Maybe I should explain it in a different way. So I'm going to try a different way to explain to you. Maybe I should go this method first. Okay, I thought it would be a good example to explain that to you. Okay, all right. I will, before I start with the application, let me explain the fundamental first. So my strategy now is to go to the types of workforce that we have, and then from there I'm going to ask you again the question just now, and then we will look into the application. Is that okay, guys? Let's go to the types of workforce that we have. Okay, all right.
Okay,
Okay.
madam.
I'm sure that after I explain the type of workforce, maybe by then, when I ask you the same question, you can answer better. Okay, we will do that. Okay, so when we talk about principle of work energy, there are a number type of work or force involved. Okay, so let's do let's start with the basic one first. Okay, the work of a force. Okay, now we start with the fundamental concept first here. Okay, so let's say you have a particle. Okay, so this particle here is going up. Okay, then there is a force acting on it. Okay, so it's going up from the position, let's say this is R, and then it's going to here R prime. Okay, all right. So when I draw this, I need you guys to draw this. Okay, so this will be dr, and this is our angle theta, and this will be ds. Okay, now, okay, so what we want to do here is basically we want to analyze the motion of the particle using work and energy. Okay, so this diagram will be able to explain that clearly for you. Okay, so we want to analyze what is the motion and we want to understand what is the concept of work and energy. Okay, so the resulting equation that I'm going to show you in a while is going to be able to solve problems that involves forces, velocity, and the other one is what? If you remember.
Displacement.
Yes, displacement. Okay. So basically, the equation that I'm going to show later on is going to be helpful for you to solve problems that is related to force, velocity, and displacement. But however, what we need to do first is we need to define what is the work of a force. Okay, so especially a force F, if you can see here, a force F. Okay, number one, the force F. Okay, the force F will do work. Okay, will do work only. Okay, on a particle. Okay, when what? when the particle undergoes a displacement in the direction of the force. Okay, so this definition is very important. So the force F will do work only on a particle when the particle undergoes a displacement in the direction of the force. Okay, so the force must be in the direction of the displacement. Okay, where do you think is the direction of the displacement? So the particle is moving, let's say from here to here. So the direction, let's say this is S1 and this is S2. So the direction of the force must be in the same direction as the displacement. So if you understand that, what you can say is, if we want to identify what is the work done, usually the symbol du is work, is equals to the force F, what? What do you think? You have to resolve it in the direction of the what?
Displacement.
Yes. So if you resolve it in the direction of the displacement, what should it be? Should it be F cos theta or F sin theta? If this is your theta. Class? This is F what?
F cos theta.
Yes, F cos theta. Remember, let's say this is your F, and then if this is your theta, if you resolve in this direction, it will be F cos theta here, and this one will be F sin theta. But right now, your force must be in the direction of the displacement. So your formula that you need to have is F what? Cos
Theta.
theta. Okay, and you must multiply by ds, the distance of it moving, okay, from one position to the other position. So this is the important formula. Okay, so the direction of the force must be in the same direction as the displacement. So when you get a question, any other questions that is related to using principle of work and energy, you need to draw the correct free body diagram. And once you have drawn the free body diagram, you must make sure all the forces are resolved in the direction of the displacement. You only consider the force that has in the direction of the displacement. Okay, all right, good. So that is something important. Okay, so as you can see here, the particle, the force F that you see here is actually what it is actually causing the particle to move along the path S. Okay, and then it's moving from one position to another position. So the displacement is what you call dr is equal to r prime minus r. Okay, all right, and the magnitude of dr is actually ds. So if you calculate the magnitude of dr, is actually equals to ds. So basically the work done by a force is this formula, du equals to F cos theta ds. So this is something actually very important for you to understand. Okay, now that you understand the work of a force, of course, in dynamics, there are many what you call different types of forces that can happen, and different types of examples, because we have lots of applications of work that we see in our daily lives, right? Which we will talk and discuss in a while. Okay, but before that, I would like to go through to you the types of forces. Maybe when I explain to you the different types of forces involved, then you will have a better idea, or the examples and application that we have. And maybe then only you can answer my questions that I will ask you just now. Okay, all right. So there are many types. Okay, there are many types of force involved. Number one is work of a variable force. Okay, there are four types actually. There are four types. You need to understand these four types. Once you understand these four types, you can maybe understand better the application Okay, so work of a variable force. So work of a variable force for each for each type, I will be drawing a diagram to make you understand better. So work of a variable force, draw this line, draw this diagram. So let's say you have a curved line here, and then you have a particle here. Okay, assume this particle is moving from the direction from here, S1 to S2. Okay, so it's similar like the diagram before. Okay, for variable force. So this one will be R1, this one will be R2. So let's say you have a force, okay, here F. So basically, if you want to have the force in the direction of the displacement, you need to resolve it like this. And this is, let's say this is theta. So this will be F cos theta. Okay, this one you understand already. So basically, if a particle is acted upon a force that undergoes a displacement from R1 to R2, or you can say from S1 to S2, the work force is determined by this integration. Okay, the work force is determined by this integration. Okay, wait, work. I've told you before, the work will be U, yeah, the work. U from U1 to U2. Okay, this is the symbol for work. And then 1 to 2 means from first position to the final position. Will be the integration of F dr, okay, from R1 to R2, which is also equals to from S1 to S2, the integration of F cos what? Cos theta ds. Okay, so this is the work of a variable force, a type of a variable force. Okay, and then secondly, we have work of a constant force. Okay, in a while, I'm going to ask you what is the difference. Okay, work of a variable force. Next, we have work of a constant force. Okay, along a straight line. Okay, so the example diagram for a work of a constant force is very simple in a straight line. Draw a straight line. Let's say you have a variable here. Sorry, variable. I mean, let's say you have a particle here with the force F and is moving in a straight line. Sorry, let's say S1 and S going to S2. Okay, all right. So this is your angle theta. So basically, what is the key? Remember, what is the key here? The force F will do work only when the particle on a particle when the particle undergoes a displacement in the direction of the force. So what do you mean? If you want to find the work of the particle, the force must be in the direction of the displacement. So you need to, again, you need to what? Resolve it. Understand?
Yes, madam.
Okay, so you need to resolve it. So for this one, this equation, the work from 1 to 2 equals to F cos theta integration of S1 to S2, the distance ds. Okay, now, what can anyone tell me what is the difference between the force work of a variable force or the work of a constant force? What is the difference? What is the difference? You can try, and if you get it wrong, it's okay.
Dekat
But-
variable force, we
Mhm.
do not dekat at the variable force we integrate the F cos theta, but not in the constant force along a straight line.
Not really. What is better to explain is the force. If a force acting on a variable force, the force always changes within time. If you notice, the force changes within time because it has a number of positions. Within time, the force, this one, the force changes within time. But when you have a work of a constant force, the force is constant. It means the force doesn't change. Okay? But okay, it's a good try. Okay? So it's very simple. For variable force, the force will change within time. But for a constant force, the force is the same. It doesn't change. okay, because the angle will change if it's a variable force, okay? But if it's a constant force, the force will be constant throughout, okay? Don't worry, when we start doing examples together, you will understand better the difference and you will understand what changes and what does not changes, okay? All right. Now, we have two more types before we start doing, we understand the application and then we can do what you call examples. We will do an example question together. Okay, next we have work of a weight. Okay, next we have a work of a weight. Okay, for this one, I'm going to draw the diagram in 3D, okay? What I mean is I have axis X, Y, and Z. Okay, so let's say we have a particle here on this curved line. Okay, so this particle is actually moving upwards. Okay, now this particle is moving upwards, but this particle has a weight. This weight is pushing it downwards, W. Okay, and it's moving from, let's say, this position S1 to S2. Okay, so here you consider a weight, which this weight of this particle is moving along a curved path from position S1 to S2. So what is the formula for this one? So the work done here from 1 to 2 will equal to negative W delta Y. So what is delta Y? Delta Y is y2 minus y1. And what is y2 and y1? Y2 is the height, this height, this height. Let's say this is y2, this height. So it means this height, this is y2. And this is, let's say this is y1. So this height. Okay, all right, because it's due to weight. So you take the difference in height here, the change in height, y2 minus y1. Okay, all right, so this is work due to weight. So when you get a question and you know that the force that is causing the particle to move is due to the weight is the force that is involved, this is the formula. Okay, this is the formula involved. Okay, don't worry, understand what are the different types of work first, and then when we go to a specific question, it will sometimes be a combination of, okay, a combination of work of weight, work of a constant force. Okay, it can be a combination, and the other combination that can happen in an example of a question is the fourth example of work, which is work of a spring force. Okay, so basically in dynamics, you can have this combination. One example question can have the particle can cause work to done due to weight or and including spring. So before we go to an examples with all these kinds of combination, it's important you understand individually first about it. So let's go to our last example before we go, last type before we go to application, and then finally we go to our example, work of a spring force. Okay, now, so do you know what is a spring? So this is an example diagram of a spring. So let's say this particle has a push force spring here. Okay, all right. And the spring, usually we have a stiffness, we have a stiffness, okay, K stiffness. Okay, so this is an elastic spring, and this elastic spring, what it can do is it can elongate and it can contract. Okay, you understand, spring can elongate and can contract. It means it can expand and it can return back to its original position, or it can be crushed. Okay, all right, so the work of a spring force, so let's say this is your particle spring force, and then you have this force. Okay, and let's say this is your distance of the spring. Okay, the original distance of the spring, and this, let's say this is your ds. Okay, usually this distance s is the unstretched string, unstretched, which is the original how the string looks like, and then the ds is the change that is causing it. Okay, so the work of a spring u, okay, equals to the integration of, okay, the integration from S1 to S2, okay, force of the spring multiplied by ds, okay. And what is the force of the spring? Usually for a spring, the formula is negative ks, okay, negative ks ds. And why there is a negative? Because you want it to return back to its original position. That's why we have a symbol negative here. So to simplify this formula, the work done due to a force of a spring will be equals to negative, okay, 1 over 2 ks squared minus 1 over 2 ks squared. So, but of course, it will be s, the final s minus the initial s. But don't forget, you need to square it. Okay, so this is the important formula. Okay. Now, so these are all the types of forces, okay? Type of work or force that can happen. Okay, are you okay, guys? So do you understand there are 4 types? Does anybody have any question before I go to the types of application? Are you okay, guys?
Okay, madam.
Okay, all right. Okay, Sabayam, before this is the fundamental, the concept, understanding the concept. So what is important here, you must understand the work of the force F will only undergo work in the direction when the particle undergoes the displacement in the direction of the force. This is a very important statement. And then you have 4 types. One is variable work of a variable force, and then you also have a work of a constant force. Thirdly, you have a work of a weight, and lastly, you have work of a spring. Okay, understand all this. Okay, now we're going to go to application. Okay, one application that is easy for me to explain. Okay, now you're gonna look at me a little bit bigger here. Okay, one example that I can show you is okay, for example, let's say I have this book. Okay, can you see this dynamic book that I have?
Yes, madam.
Okay,
You can see it.
let's say this dynamic book is on the floor. Okay, and then I want to carry this dynamic book and put it on the table. Okay, am I doing work? Of course,
Yes.
I'm doing work. Okay, but right now I'm asking you, which type of work is it? What do you
Uh,
think?
variable force.
Variable force.
Huh? Okay, all right. Why you say variable force? Why do you say variable force?
Change within time.
Okay, change within time. Okay, it can be due to variable force. And also what else? Look at this. Is it heavy?
Work of a weight.
Oh yes, it's also have a weight. Work due to variable force is me pushing it, carrying it. And the other thing, work
Work of
due
a weight.
to due to weight. Okay, now, all right. So if I have this this, what do you call this? This object, which is this book, am I doing positive work or am I doing negative work? What do you think?
Positif sebab ke atas.
No, which one? If I am carrying it from the bottom and then putting it on the table, am I doing positive work? Sekarang ni the book is on the floor and I'm going to carry it and put it on the table. Am I doing positive work or negative work? There's only one answer. What do you think?
Positive.
Pardon?
Positif.
Positive. Okay, now, okay, I'm going to share my screen again and I'm going to ask you the question again and then you're going to give me an answer, yeah? All right, okay. Okay, now. Okay, this is you sitting on the desk. Okay, so who is this? Sitting on the desk. Okay, this is your desk. Huh? Siapa ni? Who do you want this to be?
Haikal. Sebab pakai
Okay.
topi.
Okay, this is Haikal. So Haikal is sitting on this desk and Haikal, there is a book. Okay, this is a book. And you're going to carry this book and put it on this table. Okay. Now, when you carry this book and put this on this table, are you doing positive work, Haikal, or are you doing negative work, Haikal? Hmm? Haikal, are you
Yes.
here? Are you doing positive work or negative work? Okay. You don't know the answer, Haikal?
Yeah. I don't know the
Okay.
answer.
Now, can you look back at the definition? All right. Okay, let's say this book has a weight. Okay? And your direction that you're moving, this is S1 and this is S2. Okay. Now, the work is due to the weight, but your direction is going up. Is it in the same direction of the displacement?
No.
So when it is not in the same direction, you are actually doing.
Negative work.
Yes. If your if your force of work is in the same direction of the displacement, you are actually doing positive work. Okay, now let's say this is Haikal. Okay, who is Haikal's best buddy?
Aimi.
Okay, let's say this is Aimi. Okay, this is Aimi pula. Okay. Now Aimi takes this book and put it down. Is Aimi doing positive work or negative work?
Positive works, but in the direction of the weight force.
Yeah. So now do you understand? So you can only do after you have that draw the free body diagram and you have looked at the direction of the work of the force. If it's in the same direction as the displacement, then you can do the equation. All right? But if it's not in the same direction, then tak ada lah. Kan? For example, let's say I have this same another example for you. Okay. Okay, this is the box. You have a weight down put in here. You have a normal force N here, and then it is pulled by a towing force here. Okay. All right. Now, this box is moving from here. Let's say this is S1 and is going up here to S2. Okay, the direction is there. Okay, now tell me, okay, what is the first thing that you do? You need to draw the correct free body diagram, right? We have gone through this many times. So when you draw the correct free body diagram, you need to resolve this one becomes 3 cos theta. Am I right?
Yes, and
E
C
sine
sin theta.
theta, and then this one becomes W cos theta,
Theta.
and then this becomes W.
W sin theta.
Terbalik tak? Terbalik.
Balik.
Yelah. Ni W sin
Oh, betul
theta,
terbalik.
W cos theta. Okay, now, all right. So when you look at this question here, okay, I'm gonna ask you a number. Okay, now, is there work due to weight? Is there work due to weight? W. Is there?
Yes, what ada weight?
No.
Oh,
Okay. The clue is the work of a force must be in the direction of the displacement. Betul tak? So is there work due to weight? Ada. Tapi which one? W cos theta or W sin theta?
Sin.
No.
Bukan W cos theta.
W cos theta.
Theta.
Okay. Do you understand why W cos theta? Who should I ask here? Who should I ask here? Nur Adlina. Do you understand, Nur Adlina? Why W cos theta?
Faham.
Why?
Macam Madam cakap, kalau sudut tu betul lah. Kalau sudut tu dia dekat kena guna cos.
Okay, I understand cos. Tapi my question here now you need to come up with the equation due to work from one position to two, right? Which is the forces yang ada? You have to decide, is it W cos theta or W sin theta? Which one? Or both? What is the keyword? The keyword is here. Okay. The
Same
force
direction.
F will do work only when the particle undergoes a displacement in the direction of the force. Okay, so where is the direction of the displacement? From S1, S2. This direction, betul tak?
Yes, madam.
So, when you want to come up the equation of work, you only consider the force that has the direction in the displacement saja. So tell me again, when you come up with the work formula, this one work, you need to come up with the F value. What is it? So it will be W cos theta only. Why? 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 Because this is the direction of the... Can you please say this out loud?
The direction of displacement.
Because then you have to put ds here. The change from position S1 to S2. Okay, but the direction, is it positive or negative?
Direction is negative.
Yes. And then what else you have in that direction?
T cos theta.
Yes, you have also T cos theta ds. Okay, how about normal force?
Tak terlibat.
Yes, for normal force is not included. Okay, because why? Because it is not in the direction of
Displacement.
displacement. So basically, when you want to solve problems related to work and energy, you must identify the work done. And the work done are only the force that is in the direction of the... What again, guys?
Displacement.
Okay, do you understand? Okay, understand that part. That is very important because or else you will make a mistake. Okay, it must be in the direction of the
Force. Displacement.
displacement. Okay. All right. Do you understand better now?
Yes, madam.
Okay, good. Okay. Now, so this example actually is similar to this one that I mentioned just now. Oops. Okay, so the principle of work is the sum of all the forces acting on the particle, which is equal to the kinetic energy of the particle. So basically, if we want to solve questions related to principle of work energy, there is the main formula here is T1 plus work equals to T2. So if this is the work done, can you guess what is T1 and T2? Can you guess? The work done is sum of all forces. Okay.
In the direction of displacement.
Yes, but what is T1 and T2? This one.
T1 is W cos theta.
No, T1 is?
Kinetic energy.
Yes, T2 is? Kinetic energy. Okay, so basically if you want to solve the problem related to work energy, the first step is you need to write down this formula. And then what is kinetic energy? Kinetic energy equals to T1. Okay, it also equals to T2. And the formula is 1 over 2 mv squared. So if you want to do for T1, it will be 1 over 2 mv squared, but the velocity will be the initial velocity. And for the formula T2, what do you think? It's the same formula, 1 over 2 mv squared, but for the final velocity. because your particle is going to move from one position to another position. So you will have an initial velocity and you also have a final velocity. And the units for kinetic energy and work is joule. Okay, guys? Are you okay? All right.
Yes,
Now,
madam.
okay, good. Okay, I think you understand now. What I'm going to do is I'm going to give you the steps to solve the problems. And once I give you the steps, we can try to solve the question. Now, have you copied that question that I sent to you through WhatsApp?
Done
Done,
copy.
madam.
Done, eh? Okay, now let's talk through the procedure. Okay, now we're going to go through the procedure. Okay, what is the procedure? Okay, the procedure. Number one, you must be able to do what is the work for the free body diagram. Once you identify the free body diagram, then only you can continue. So how do you identify the free body diagram? You need to account all the forces that is involved on the particle in the direction along the path that it is moving. Okay, so if you, let's say this is your particle, this book, all the forces that's acting on the particle, you must take into account. Okay, and then you must make sure the forces acting of the particle that you want to take account must be in the direction of the path that it is moving. Okay, all right. Secondly, you're going to apply the principle of work energy. Okay, principle of work and energy. And the formula for principle of work energy is T1 plus work. Okay, usually summation, T1 plus work from 1 to 2 equals to T2. So this is the principle of work energy. Okay, all right. And then what you know, the kinetic energy, what is the formula for the kinetic energy? The kinetic energy, you will have a kinetic energy for the earlier position and also for the final position. So the kinetic energy, the formula is 1 over 2
1/2 mv squared.
mv squared. Okay, all right. And then the concept that you must remember, a force does work when when what?
When it goes in the direction of displacement.
Okay. Okay, I don't know when it undergoes the
Direction
direction.
of displacement.
Okay. Okay, this is very important because you know dynamics, there is a lot of topic. Newton's second law dia ada cara lain. Betul tak? Normal and tangential dia ada cara lain. And then constant acceleration ada cara lain. But all these different ways and methods are different. So when you get a question, if you understand the fundamental concept, no matter how difficult the question is, you can solve it. But if you don't understand the concept, when you get a question, you main hentam je buat. Betul ke tak betul, you tak sure. Itu yang tak best. Itu yang saya tak nak. Faham tak? But if you understand the concept, no matter how difficult the question is, you strongly believe in the concept where the force does work only in the direction of the displacement, and you only consider that, you will get the answer 100% C plus, you can get maybe B minus or B plus, or instead of getting B plus, let's get an A minus or A plus. You understand? Okay. All right. Work for the best. Yeah. And then what do we understand just now? Work is positive when what? When is work is positive?
When it is in the direction of the displacement.
Yes, you give the answer exactly given in the textbook. How hebat you are. Okay.
Thank you.
Okay. is in the same sense of direction, okay, of its displacement. Okay, that's what we want. Okay, you are the textbook. Okay, all right. And when work is negative, when it is not in the same direction, opposite lah, vice versa. So you understand that, And then lastly, um, uh, and then lastly, work of the weight. The work of the weight. This one you can have what? Positive, negative lah. Work. And what is the work of the weight? Sekejap padam sikit. Tak nampak apa itu. Work of a weight ni ini I tulis positif, atas ni positif dan negatif Work of a weight can be positive and negative, and dia punya answer tu, sorry, let me write it again nicely. Tak kemas. Work of a weight tadi, it can be positive, it can be negative, and it is what? W delta Y lah yang tadi Okay, so how do you know the work of a weight is positive? When is it moving downwards ke moving upwards?
Because of weight when it moving downwards.
Yes, when it goes downwards, So it means when you get a question that is involving work of a weight, tiba-tiba you get the answer to it, the object is moving down, tiba-tiba you get the answer negative, mesti ada salah. Faham tak? Because when the work is due to weight and is moving downwards, sepatutnya dia positive. Okay? Sometimes you can detect earlier the mistakes that you did. Okay? And then lastly, work of a spring. You understand the work of the spring is what? 1/2 K S squared. Okay, all right. So those are the important things for the concept and then fundamental of understanding work of a way. Using principle of work and energy. Okay, now so it's not that difficult. When we start doing questions, exercises, you will find it very easy. Same as principle of linear and impulse momentum. But this one is not today lah. Okay. Or it will be too much lah for us to finish off today. Hello guys, can you hear me? Boleh?
Boleh madam, walaupun
Okay.
sangkut sikit sebab peti-peti ni.
Oh, kenapa tak petir kat sini? Kat sini hujan pun tak. Sana dah hujan
Baru nak habis, tapi guru-guru peti tu ada lagi lah.
I see. Okay, it's okay. Ada recorded video. You can watch it after class if you want. Okay, if you don't want, it's okay also. But you have written the notes and understand. Okay, now, okay, we had talked for 1 hour already. I have talked for 1 hour already. So I will give you like a 5 minutes break. I want you to copy this question. For those yang belum copy, okay, we're gonna do these 2 questions in class, okay, together, okay, and then after that, okay, and then we're gonna do this question. So for those that have not copied this question, tolong copy this question now, and then we will try to solve this together, All right. So I give you, like 5 minutes break, boleh?
Boleh madam.
Okay, all right. Is who
Sure,
is still
madam.
here? Siapa kat sini? I kena presenting lah kan? Oh, tapi I dah hantar kat WhatsApp kan? So you can copy it at WhatsApp So kat sini we are now still 15. Is Dr. Iliani here ke dia dah leave?
Alif rasanya tadi
I
dengan
see.
profesor.
I see. Profesor Madya, Dr. Cik Khairil tadi sekejap je?
Sekejap je.
Okay, never mind.
Tak sampai setengah jam pun dia dah leave.
I see. Tapi it's okay. I'm just doing the same thing that I do normal. Tak adalah apa-apa different sangat. Cuma suruh you salin lebih awal lah. Okay. Right, 5 minutes break. I pun nak stretch my body sikit. Oh. Okay, so bolehlah I kembali kepada apa background I tu.
Boleh,
Kembali
madam, boleh.
kepada background I. Okay. Okay, what happened to Faiz Did you dah forward his number?
Saya dah kasih dalam grup WhatsApp tu ke nak PM madam
I
ni?
see. Dah bagi kat grup WhatsApp Oh ni. Okay, nanti I try to contact ya. Dia kelas lain dia join tak?
Tak. Daripada minggu ke berapa dah, dia memang dah tak start join kelas langsung.
Okay, bila I tengok sistem Evans pun, dia masuk, dia join tapi dia dah stop bulan lepas. Hmm. So I kena find out lah PA dia siapa. PA dia sama dengan you all ke?
Sama, PA kami semua sama.
Siapa?
Encik Warid Wazin.
I see. Okay, nanti I contact. Okay, alright. Aimi, you boleh minum air ke apa? Rest.
Nak isi air je.
Nak isi air. Okay, pergi isi air. Alright. Nanti sekarang dapat 13. I bagi kita masuk balik dalam berapa minit you nak?
Sini 5 minit boleh je.
5 minit lah. Okay, 5 minit. Okay, nanti kita kembali
Okay, madam.
Okay, bye. Hello, I'm back. Did I take too long?
Nope.
Okay, you all guys.
Tak boleh lah.
Hmm?
Tak boleh.
Okay, bawa dia naik. Okay, you must understand guys, kita punya kelas 3 jam panjang
Masing.
Dia macam panjang lah masanya. Penat lah. I harap you all tak penat Kenapa you all bilik sama, seorang gelap, seorang terang?
Saya pun tak tahu.
Kenapa dia gelap? Okay, never mind. Okay, dah siap ke jawapan tutorial tu? Buat sendiri tak? Ke tunggu saya juga? Manjanya. Okay, siapa yang saya message minta solution tak jawab Solution. Sorry, bukan solution. Saya minta nota. Siapa yang saya minta? Tolong angkat tangan. Saya randomly pick tau. Siti Zaratul. Lagi? Siapa lagi?
Saya.
Anis, Aimi. Lagi? Okay. So bukan baru buat Dah lama buat kan? Okay.
Dah lama, sehari selepas video dihantar.
Sehari selepas video dihantar. Okay. Alright. Okay. Kita dah rest lama So kita boleh continue Okay, now kita nak jawab soalan ni Okay. Ada tak yang dah cuba? Belum. Belum juga. Manja you all ni? Aduh, tapi itulah. That's why kelas saya suka buat sama-sama. Because I know this will happen, you know? Okay? Alright, now. Okay, let's do this together. Red pen Okay. Now. 1,000.
Madam tak share screen ke?
Oh, saya tak share screen. Ya Allah. Okay. Okay, now can you see my screen?
Yes, madam.
Okay. The 1,700 kilogram automobile shown travels down the 10-degree incline road at a speed of 6 meters per second. If the driver jams on the brakes, causing his wheels to lock, determine how far as the tires skid on the road. The coefficient of kinetic friction between wheels and the road, mu k, is 0.5. Okay, actually, when you read this question, you mesti fikir, kenapa I tak solve this question using Newton's second law? Pernah terfikir tak? Tak. Kenapa I tak solve this question using constant acceleration formula? You pernah terfikir tak?
Tak.
Sebenarnya boleh. You can solve using the constant acceleration formula whereby you need to find S.
Displacement.
You need to find S. You can use that and you can get the same answer. But however, to find S, you need also to find S dalam formula tu yang constant acceleration ada A, so you need to find A. Tapi tak apa. Now kita solve the problem using work energy and then after this I'm going to show you for the same question you can solve using constant acceleration formula. Boleh?
Boleh, madam.
Okay. Now kita nak guna work and energy dulu Okay, now remember what is the first step? What do we need to do?
Free body diagram.
Okay, boleh tak you draw the free body diagram?
Boleh, madam.
Nah, tak gerak ni.
Dan.
Sorry, I punya ni tak bergerak. Hmm. Okay. Sorry Apa dia merajuk ni? Time ni lah dia merajuk. Dah masih hujan ke?
Dah macam dah stop.
Tak,
Macam dah stop.
tak sampai sini ke hujan tu. Okay, now, so for this question, first we need to draw the free body diagram. So you know that you have a weight, and then you know that you are the normal force, betul tak? And you know you have a friction. The friction, coefficient of friction, the frictional force, will it be going down the hill or up the hill?
Up the hill sebab kereta tu yang turun bawah.
Okay, frictional force. Okay, so you have all that in that diagram. Okay, now for this question, apa yang dia minta? I want you to use work energy. So remember the formula? T1.
T1 plus U 1
Mhm. Sekejap,
1
my pen besar tebal ke? Okay. Equals to?
T2.
Okay, T2. Okay. Now, what is T1 formula?
1/2
Betul? MV squared.
MV squared.
Okay, now V1, what is the initial velocity?
6
Yes, that's correct. 1/2. Okay, I punya screen ni dia what do you call pen ni dia lagging lah. Kenapa lah? So 6. Tapi you can see my thing moving
Yes, we can see.
Okay. So sorry. Terus gantikan dengan the mass. What is the mass? Patutnya terus gantikan dengan the mass
1750 kg.
1750 kg kali 6 square. Okay. So that is your T1. Okay. Tolong calculate siap-siap So what is your T2? What is your velocity for V2?
Tak tahu.
Tak tahu ke? Tahu.
Sama 6.
Tak sama. Cuba you read the question. If the driver jams on the brakes, causing the wheels to lock.
Kosong.
Yes, kosong. Please read the question carefully. So the driver jams the brake, causing it to so it means V2 kosong. So 1/2 M V2 ialah kosong. So ni jadi kosong je lah. So T2 ni kosong. Okay, alright. So what is your work? Okay, now you have to look at the work. The work must be in the direction of the displacement. So you need to, if you need to resolve, you need to resolve in that direction also.
Okay.
So what kind of work do you have? So
Work.
this one, you if you resolve it, you have W
W cos theta.
sine. Ni W cos. Kan, ni W sine. Ni ya Allah. Okay. Why? Because this is your angle theta. Okay. So if in the direction of the displacement you have W sine theta. W sine
Theta.
Apa pen ni ya Allah. W sine theta. Okay, kejap. I cuba cabut balik pen ni. Mana dia punya ni. Okay, sakit belakang pula. W sine theta. Is it positive or negative?
Going in the direction of positive.
Positive. And then jangan lupa you must multiply dengan distance tu. Which is S lah. Okay? And then what else you have?
Friction force.
Okay, so kita dah tahu dia negatif, mu, K, and jangan lupa multiply S ni. Selalunya student bila dia buat work energy method, dia tertinggal ni perkataan ni, S ni, kat belakang ni. Sebab now you're doing work and energy, right guys? Bila you do work and energy, you need to include that S. So jangan tertinggal that S. Because in this question, you want to find that S. Okay? Selalulah student buat silap kat sini. Okay? Alright, so tolong terus simplify ni. Okay, tapi dekat sini ada N. So you need to find the normal force. So macam mana nak cari normal force? Nampak tak? Normal force sama dengan W cos theta. Betul tak?
Betul.
So for that one, you have to find the normal force first. So you can do formula Fn equals to 0. Dan arah dia macam ni, positif. So bila you buat macam tu, you ada N lagi minus W
Cos theta.
cos theta. Okay, equals to 0.
0.
So NU apa? Positif lah.
Positif cos theta.
Okay. Tolong masukkan semua formula ni. So ni formula dia macam mana? Dia samalah W sama apa? mg lah. So M kita berapa? 175 kosong. Okay, tolong boleh tak you guys tolong selesaikan ni buat kejap. Saya nak try apa? Keluar balik daripada whiteboard ni. Mungkin dia hang sekejap. Sekejap membuat IX sekejap. Masuk balik. Buat Hanis buat Ni Hanis, Putri. Lady so quiet Ya. Azim, Ali ambil phone mama. Kejap. Bateri laptop tercabut. Siapa tu? Hello.
Hello, madam.
Sorry, I punya
Bateri habis.
Hello, madam.
Bateri laptop I termati.
Dah agak dah.
Sorry. Sebab I perasan dah tercabut. I punya laptop ni tak boleh Alim. Allah. Alim. Okay. Macam itulah. Okay. Alright. Okay, I rasa dah tak ada problem kot. Okay, I share balik I punya screen. Okay, dah dapat jawapan dah? Senang je kan?
Senang.
Senang. Okay, screen saya nampak tak?
Belum lagi.
Belum.
Tak nampak lagi.
Okay. Sekarang?
Baru nampak.
Baru azan pula.
Tak,
Okay.
tu orang tengah solat.
Oh. Okay. Alright. Bukan kat sini kita. Kita tadi kat mana? Berlainan-lainan saiz. Aduh. Apa dia tak nak enlarge
Tak pasti.
Okay, sekejap. I buka whiteboard baru je lah. You all dah salin kan jawapannya?
Dah.
Sorry lah hari ni ada banyak glitch pula tiba-tiba.
It's okay, madam.
Whiteboard I tak nak buka. Kenapa? Kenapa tak nak buka? Ada cara lain ke pakai whiteboard ni? Kalau PowerPoint boleh ke? Kenapa tak nak buka? Okay, kalau I buat kat PowerPoint, macam mana nak counting screen kat PowerPoint? I so nampak orang buat tapi I tak pernah buat. Draw. Pen. Tengok working tak? Okay, nampak tak?
Nampak, madam?
Okay. Alright, kita kembali. So, formula kita T1 plus work ke T2. Okay, T2 kita kosong. So, T1 kita dah dapat tadi. Apa? T1 I tak calculate tapi it's half of M and then multiply dengan 6,
Velocity.
betul tak? Square.
Yes.
And then plus dengan work kita dah identify ada 2. One is due to the weight where you buat 1750 sin kan? Sin 10, jangan lupa kali S and minus the frictional force. Mu K kita berapa? 0.5.
Yes. 1750 tu kena darab 9.81 kan? Sebab weight.
Yes. Kali dengan G. G berapa? 9.81. Betul. Okay. And then minus 0.5. Normal mu K. And then normal force kita ialah 1750. Normal force kita adalah W.
Cos
G jugalah ada 9.81. Betul?
yes.
Tapi cos theta, jangan lupa ada apa?
S.
And then equals to 0. Okay. Kalau during exam, saya cadangkan you calculate asing-asing boleh tak? Sebab bila panjang macam ni, you boleh buat careless mistakes. So from here you dapat S. S dapat berapa?
Ya.
Punyalah lama tadi. Saya punya komputer ni. You buat apa? Ayo. Buat apa tu? Ini kalau depan mata ni boleh rotan ni. Buat apa tu?
Janganlah rotan, madam.
Saya dengan anak saya rotan je. Geram kadang-kadang. 4 boys kan? Okay, S berapa? Putri, S berapa Putri?
Baru nak kira.
Baru nak kira. Aduh, Put. Oi, Put. Put kita pun. Baru nak kira. Kenapa lambat? You wasn't confident ke? Hmm? It's okay, Put. Kan? Itulah Putri. Putri apa nickname ah? Putri Put Tak Tak pernah ada orang panggil you Put. Okay, Putri berapa
Putri
Putri?
nickname je princess lah.
Yelah, Princess ialah nama semua orang nak. Kan?
5.76 madam.
Betul. 5.76 apa Put? Meter. Okay. So you dah dapat jawapan dia. Now,
Oleh siapa?
let's say soalan ni dia tak bagi tahu use work and energy. You boleh juga dapatkan S ni using constant acceleration formula. You guna formula ni. V squared equals to V naught squared plus 2AC S minus S naught. Kalau V squared kita tahu V squared kosong sebab final dia kosong. V naught berapa? 6.
No.
A kita kena cari. S kita apa? S lah kita kena cari. Initial S kosong, starting dia kosong. So maksudnya kita kena cari A. So untuk cari A ni kita boleh guna Newton second law formula tau. F equals to MA. So F equals to MA in in direction macam ni. So kita ada apa? Kita ada kalau ikutkan dalam gambar tu kita ada apa? mg sin theta, apa lagi kita ada? Minus
Friction force.
UK
Okay.
N. Equals to 1750A. So semua value ni kita ada. Kita boleh cari A. Tapi ingat bila you guna Newton second law ni, apa beza dengan work? Work tu nampak tak? Dia ada S. Jangan
dia ada
tertinggal S tu. Okay? Kalau you guna Newton second law tak ada. And then you dapatlah A. So kalau you calculate A cepat-cepat, berapa? M kali G kali sin kali 10 minus 0.5 kali N equals to 1750A. Dapat A dapat apa? Cuba kira quickly.
1750
Dapat apa? Acceleration dapat apa?
10 minus 0.5 times
Dapat apa? Dapat sama tak?
bahagi 1750 3.127 negatif.
Negatif betul. And then you masukkan dalam formula ni untuk dapatkan S. Dapat sama tak? Sama tak 5.76?
6 square
Dapat sama tak dengan ni? Dapat kan?
bahagi
Right.
Okay, good. So basically, if they don't mention the if they don't mention the method, you can use both method to solve the same question lah. Okay, now let's go back to the question. Ada lagi satu soalan saya bagi, betul tak?
betul.
Okay, now dah salin dah yang ni? Okay. The 40 kilogram boy slides down the smooth water slide. If he starts from rest at A, determine his speed when he reaches B. Okay, nampak tak boy tu? Dia dekat A, dia naik tangga atas tu, and then dia slide bawah tu sampai ke point B. Okay. So, determine his speed when he reaches B. So, soalan ni dia nak speed. So, dia nak V. Tapi dia nak V bila reach point B. And the normal reaction, the slide exerts on the boy at this position. So dia nak normal reaction berapa. Dan untuk soalan ni, I nak you all guna work and energy. Okay. So number one, what do you need to do? You need to draw the free body diagram. Okay, sebenarnya where do you need to draw the free body diagram? Dekat the boy lah, betul lah. The boy is the particle that is moving, betul tak?
So,
Okay, so let's draw back the boy. Okay, who is this boy?
Ini.
Gabi Aimi. Kalau Aimi kena buat tembam sikit ke?
Ha.
Okay. So Aimi rambut dia macam mana?
rambut saya macam budak net.
Macam tu.
Tinggal
Ni
tepi.
Aimi. Okay. So Aimi ni Aimi. Okay, sekejap. I rasa nak tukar colour pen. Oh, saya nak tukar hitam. Okay. So, oh dia tak nak tukar. Okay, never mind lah. Okay, so untuk this question, boleh tak you all draw the free body diagram? So, the Aimi is going down macam tu. Okay. So, bila Aimi is going down kat sini, tangent to the path, kita tahu ni T. Ini adalah normal dia lah. Okay. Alright. So, kita akan draw dia punya free body diagram. Dia ada apa? Of course, dia ada weight. And then kita akan draw N. Of course, dia akan ada normal force dia lah. Okay. Alright. So, ini N, ni W. Okay. So, kita dah draw free body diagram. Next, kita kena sebab ni PowerPoint kan. Dia macam tu lah. Sekejap, So, kita kena draw the formula, write down the formula which is T1 plus work equals to T2. So, T1, apa T1 kita? 1/2 mv squared. Okay. What is our velocity?
0
Why?
at rest.
Betul. At rest. Mana rest? Okay. So, this one is 0 lah. Okay. You buat macam ni, buat 0 macam ni, you dapat markah T2, you write down this formula pun kadang-kadang you dapat markah. Ni, you dapat M1, ni dapat M1. Macam tu. Okay, what is T2? Do we know the velocity at point B?
No, that's
No.
what we have to find.
Okay. So, since soalan ni ada A dengan B, you bolehlah buat T1 jadi A, T2 jadi B. So, velocity B, dia bolehlah buat macam ni. So, this is what we need to find lah. Okay, we need to find the velocity at B. So, now, let's identify the work. Now, what work do you have in this question?
And W sin theta.
Yes. Are you sure? How confident are you?
Super duper very very confident.
Because kita textbook.
Why? Huh?
30. Sebab ada weight. Tapi tak ada angle.
Now, apa formula due to work due to weight?
Formula due to weight. Negative W delta Y.
Yeah, so you have to use this. So what is negative W? Negative mg lah. And what is delta Y? Y2 minus Y1. Okay, now. Okay, I sambung ke atas ni Okay, so what is mg? M, what is the mass? 40. Jangan lupa ni, what is this? Negative. Jangan lupa this negative. Okay, negative 40. G berapa?
9.81.
Okay, what is Y2?
Y2 0.
Sure? Okay, what is Y1?
7.5.
Okay, sebab Y2 is the final and Y1 is the initial. So, dia punya initial ialah dekat sini. Dekat point A. So, bila dia punya initial kat point A, so this will be our Y1. And dia punya final kat sini. So, this will be Y2. 2. You
2.
understand? So that's why it's 0. That's why bila you notice negative jadi
Positive.
so remember just now what did I say? When due to weight, when it's in the same direction as the displacement, dia adalah positive.
Positive.
Positive work.
Yes, positive work. So negative 40 times 9.81 multiply negative 7.5 dapat berapa?
2943. Betul ke?
I don't know. You all tekan calculator.
Saya dapat 2943
Okay.
joule.
Harap-harap betul lah. Okay. So now you need to put this in the equation. Equation apa? Yang tadi T1. So T1 kita kosong plus 2943 equals to 1/2 apa? M kita? Mass kita 40. Aimi. Boleh betul ke you 40 kilo?
Hah?
Aimi? Berat you betul ke 40 kilo?
Berat saya double, madam.
That's why. Ini bukan Aimi. Tak boleh jadi ni. Pak
Ini anak
Aimi
medium
mana boleh
tu,
40
yang
kilo.
hihu-hihu tu.
Hiho-hiho tu dia pun 45 kot. Hiho-hiho. Okay, VB squared. So can you find me what is VB?
12.13.
Yes, betul. Tepat sekali. 12.13. Jangan lupa meter per second.
Did you hit one message? Go to one.
Mama ada kelas lah. Nantilah.
Hai.
Okay. Alright, done. Dapat?
Alright.
Hai.
Okay, now. Okay. Itu you dah dapat velocity. Now the next question apa? Normal
Okay,
force.
Normal.
Okay, dia nak normal force. Tapi dia nak normal force dekat mana?
Boy.
Boy? Apa?
At this position.
At this position tu at B lah.
Oh.
Okay? Alright. Kita go to next slide So, Aini bila dia dah sampai dekat point B tu, dia macam terbaring, betul tak?
Betul.
Juga.
Okay, dia terbaring. Nampak buncit sikit. Tak adalah. Okay. Okay, Aini. Okay. Nanti cerita. Okay, so bila Aimi dekat position B, dia ada weight,
Wait.
dia ada
Normal force.
normal force. Okay, so sekarang ni what you need to do is you need to find what?
Normal
The normal
force at
force
B.
lah. So you can use the equation yang sama, Fn
F1.
equals to MAN. Okay, summation forces Fn equals to MAN tapi positive upwards. So what do you get? So you get N minus apa? Weight sama dengan apa? Mg je lah.
Mg.
Equals to MAN lah. So N is equals to apa? MAN minus plus lah. Betul tak? Plus kan?
Betul.
Okay. So what is AN? AN equals to V squared over rho. Ingat tak formula ni?
Ingat.
So V tadi kita dah dapat. Tadi siapa cakap 12.13. So what is our rho? Rho yang kita kena cari. Okay. If you remember dia tadi. If you remember tadi ada this equation ni.
Ya.
Okay. So this equation represent apa? This curve. Y equals to berapa? 0.075
X squared.
x squared. Okay, now do you remember the formula untuk dapatkan rho?
Rho 1 plus dy dx.
Yes.
Squared.
Square 3/2 divide by
Apa palang. D squared y over dx squared.
Okay, so if this is your y, what is your dy dx?
Dy dx buat 2 depan tolak 1
Berapa? Kosong?
point.
Ha?
0.075x.
0.1. Kenapa dia tukar color ni?
0.15
0.15
x.
x. Betul. Kalau you buat d2y dx squared, you integrate lagi 0.15 lah.
Yes.
So, okay. Now, x tu you nak ganti dengan apa?
X tu ganti dengan
Berapa x tu dekat point B?
kosong.
Betul. Tepat sekali.
Oh my god, betul.
Buat sendiri ke?
Ya.
Buat sendiri.
Buat sendiri, fikir sendiri.
Ya, betul.
Itu yang kita nak. So dapat berapa? Sebab you faham. You understand the x at point B is 0. Sebab kadang-kadang student dia tak confident kan? Dia tengok ada 10 meter lah, ada 7.5 meter lah. Okay. So berapa?
0 1 bahagi 0.15. 6.7.
6.7.
Betul. So you need to put 6.7 kat sini untuk dapatkan acceleration. Dapat berapa?
22.
20?
Salah bahagi
Berapa?
ke? 22. 22.
22
Ha,
meter per second square. Okay, masukkan dalam formula ni dan dapatkan normal force. Sekejap, phone bunyi pula.
40.
Hello?
Darab 22.
Tengah kelas. Okay. Tak, teaching and learning. Tak. You apa? Jawab tak apa? Tak. Semua penyelaras ialah teaching and learning.
Aku tak perasan.
I don't know. Yang I tahu semua penyelaras kat fakulti I bukan. You tanyalah uni coordinator. Okay. Okay, bye. Okay, sorry okay, apa tadi? So you dapatkan normal force dapat berapa? Come on, girls selalu cepat calculate ni. Dapat berapa?
1272.
1272.
2.
Betul?
Ada
Mungkin
point
you
empat.
ni-
Ada point 4.
Oh, boleh lah. Lebih kurang lah. Mungkin ada titik perpuluhan So kalau dalam kilonewton 12 jadi 1.27 lah. Okay. Alright. So unit newton boleh lah. Okay. Alright. So itu cara you dapatkan jawapannya. Okay, good. Alright. Okay, now we need to do another example. Okay, penat ke? Boleh lagi tak ni?
Boleh.
Sebab ada satu lagi jawapan, satu lagi soalan on radial and transverse guna Newton second law. Saya tak ajar. Ingat tak kita tanda and lightning? And then you all ingat tak you all punya kelas kan 3 jam. You all sebenarnya tengok recorded video yang 2 jam.
Betul.
So sebenarnya ada satu lagi recorded video you all tak tengok lagi. So sama ada you nak tengok video tu, nak fahamkan ataupun saya yang buat dalam kelas ni. So you can choose lah. Which one you nak.
Buat
Okay,
dalam
sekejap lagi I tanya you balik, you nak yang macam mana ya? Okay, alright.
Okay.
Alright. Saya sambung one more question boleh?
Boleh, boleh.
Okay. Alright. Now, sebab you all kena faham during the Alin. Iu tepi. Okay. Janganlah Alin. You all kena understand during the exam, during the test, untuk soalan work energy ada banyak jenis kan. So sekarang ni kita nak try yang pulley. Lepas tu ada lagi satu yang ada spring. Tiba-tiba yang during exam dia keluar spring. Tapi you belajar all the other types. Tak boleh lah kan. So we need to cover all the different types. Because you don't know which one yang akan keluar. So as long as you cover all the different types, tapi soalan dia ubah-ubah sikit, at least you know what to do. Okay?
Okay, madam.
Saya tak nak lah tiba-tiba, oh yang keluar jenis pulley. Tapi example kita buat semuanya dekat atas incline plane. Nanti you all akan, tak nak lah you all bagi alasan, tak ajar lah ni lah kan. So kita nak try all the different types lah. Okay? Blocks A and B, if you nak break bagi tahu ya. Blocks A and B have a mass, salin ya.
Mama dah message Mama. WhatsApp Mama, Mama panggil Mama Dada apa?
Abah.
Apa? Bye bye. Bye bye. Dada? Apa Dada?
You all tengah salin ke? Senyap je, sunyi pula. Selalu dengar ada suara background Aimi dengan ni. Haikal lah.
Termute.
Itulah Putri nak dengar. Janganlah.
Bila pula kami menyanyi?
Allah.
Oh.
Tak. Saya nak padam.
Alhamdulillah.
Hilang dah ke? Taklah saya nak padam.
Dah.
Macam mana nak padam? Mana pemadam? Mana pemadam? Dia tak ada pemadam lah.
Tu atas sebelah tu.
Oh ni. Okay. Besar sangat. Okay. So tadi you all dah berkenalan dengan Dr. Iliani kan? So nanti lepas apa? Midterm break, lepas cuti SEM, saya akan serahkan kelas untuk dia continue lah. So you all akan dia akan fokus untuk topik chapter 4, 5, 6 lah.
Okay, madam.
Rest.
Ha? Kenapa?
Alif cakap alright je.
Dia tak ajar you static dulu?
Tak.
Madam Norisha punya ajar.
Oh, Madam Norisha. Ya, you all ada bagi tahu. You all tak berkenalan dengan group kelas lain? Alim, please lah. Aduh. Mi, let me just
Tak.
finish this class. This is
Tak, madam tak berkenalan.
Huh? Ya, you all tak berkenalan. Sedihnya. Okay, dah salin dah?
Tengah melukis.
Okay, so. Kenapalah kelas you all 3 jam macam lama betul. Patutnya kita ada 2 jam and then break and then besok ke lusa lagi sejam tu better lah.
Sebab kami tak ada kelas hari Jumaat ke.
So you dah cram lah. Berapa jam semester ni? Kelas?
Lain-lain. Saya 15, Aimi 22. Oh.
Ui, kenapa tu? Tak dapat pengecualian kredit ke tu?
Aimi kan daripada Asasi.
Saya asasi
Oh,
tak
you
dapat
lain-lain
Haikal poli.
Oh. Okay.
Sekarang pukul 7.30, Koko pula.
Oh ya ke? Tapi online kan?
Online.
Yes,
So you buat apa? You buat exercise dengan senaman apa? Di dalam apa? Dalam asrama macam tu?
Yes. Dah lah. Koko
Ada rekod tak diri sendiri? Ada tak kawan you rekod tengok you buat macam tu? Rasa tak share?
Nak rekod macam ni dua sama je Koko.
Menari madam, menari.
Alah, macam lah tak boleh tekan apa phone tu and then apa tu timer kan 10 second kan berlakulah somebody yang record. Aduh. Okay. Betul lah.
Dah, madam.
Dah, okay. Alright. Block A and B have a mass of 10 and 100 kilogram respectively. So block A ni 10 kg lah. Block B ni 100 lah. Okay. Determine the distance B. So kita nak the distance B travel when it is released from rest to the point where its speed becomes 2 meter per second. Okay. So for this problem, so kita nak apply konsep principle of work and energy. So sebab ni ada 2 blok serentak. Maksudnya you ada 2 partikel. Macam mana kita nak selesaikan problem yang ada 2 particles ni dalam satu equation work energy. Tiba-tiba kalau saya tak ajar tiba-tiba keluar macam ni, you buat separate ke? You faham tak? So that's why we need to do different types of exercise so that you know how to solve the problem lah. So for first you have to draw the free body diagram lah. So senang lah. Untuk block B dia ke bawah W. Block A pun ada ke bawah W. And then ada tension force ni lah. Okay, now for the block, so kita ada work energy. So kita tahu kita ada T1 work equals to T2 lah. Now untuk T1 okay, untuk T1 apa dia punya formula? 1/2 mv squared kan? So what is the velocity for T1?
T1 velocity dia kosong sebab release from rest.
Okay, so basically ni kosong lah, tak apalah. So kita buat untuk T2 dulu. So T2 ialah 1/2 MA VA squared plus 1/2 MB VB squared. So if you get this kind of question, you boleh equate together macam ni. Okay, tapi dia separate lah. Dia ada mass A, VA, mass B, VB lah. Dan VA dengan VB lain. Dia punya velocity. Okay, so mass MA berapa? 10. VA, do you know what is VA?
Tak.
Okay, kita tak tahu what is VA. Do you know what is VB?
2.
Yes, kita tahu VB2. Okay, so maksudnya sekarang ni VA is unknown lah. Okay, tapi soalan ni dia nak apa ni? Determine the distance B. So maksudnya untuk soalan ni dia nak distance B travel. So dia nak the distance dia travel lah. So dia nak dia sebenarnya nak delta SB. Berapa? Okay. So ini kita dah buat T2. So kita dah faham dah. Now work. Work pula. Now apa work yang kita ada? Kita ada work due to weight
Weight.
lah. So work due to weight kat sini sebab kita ada dua, kita boleh buat satu untuk
B
mass.
satu untuk A.
And then kita tahu W adalah mg. So kalau 10 kali 10 kali 98.1 lah. 98.1 multiply by change. Change apa?
In Y.
Yelah.
In
Tapi
displacement.
displacement tapi kita buat change SA lah. So change SA ni positif negatif ni ada di dalam ni lah. Lagi satu dia
Takut tak geram.
tu siapa tu?
Haikal, laptop dia
Oh.
sangkut-sangkut je.
Okay, you tak ada kawan lain kan kat situ? Bunyi macam ada third person lah. I takut lah. Okay. Alright. Tak ada tak ada third person Okay. So ini change in SA, change in SB. Okay, kenapa I tak letak positif negatif kat sini? Sebab nanti dalam ni ada change tu. Kita tak tahu the direction tu. Okay. Alright. Okay. So tolong letakkan dalam equation yang panjang. Okay, macam nak letak dalam equation yang panjang tak muat. Saya buat dekat screen sebelah Macam mana nak enter page. Ni tulisan saya besar betul kot. Okay. So kalau kita put in the equation. So tadi if you remember equation dia macam ni. We support of work energy. So first kosong plus apa tadi? 98.1 change SA plus 981 change SB equals to tadi apa? 1/2 10 VA squared. Kita tak tahu VA plus 1/2 100 VB squared. Oh, VB kita tahu. Macam nak back? Ada tak previous? Oh tak. Okay. Padam. Okay. Tadi ni berapa? 2. Okay, now. Cuba you tengok. Ada banyak unknowns ni. Nampak? Delta SA, delta SB, ada VA. So, kita kena eliminate the number of unknowns. Okay. Ingat tak the length of the spring? So, kita length of the spring sama dengan total length. So, kita ada SA plus SB equals to total length of the spring. Okay. Kita punya SA dengan kita punya SB ni. SA berapa string untuk SA ada satu je kan? Untuk SB kita ada berapa? Kelas? SB kita ada berapa string?
2 kan? 3.
String.
Okay, tukar colour. Ada colour lain tak? Ni biru. Biru. Okay. Ni, 1, 2, 3, 4. So, berapa?
4.
Okay, 4. Mungkin diagram I tak berapa cantik kot. 4. So, kita SA plus 4 SB sama dengan total length. Tapi sekarang ni kita tahu bila kita cakap pasal delta SA, part delta SB, dia boleh sama dengan kosong lah. And then bila kita integrate, dia jadi apa? Velocity, betul tak? Kelas, betul tak? Bila kita integrate position, dia jadi velocity. Differentiate. Bila kita differentiate length, dia jadi?
Velocity.
Velocity. Okay, so bila kita differentiate, dia jadi velocity. So sekarang ni, kalau kita nak mudahkan, kita make kita nak mudahkan, kita nak eliminate unknown VA ni, kita jadikan ada dalam sebutan VB. Sebab VB kita tahu. VB kita berapa? 2 kan? So kalau VA sama dengan 4 VB, VA sama dengan negatif 4 VB. So VA jadi berapa? Betul tak? 8. Betul tak? Negatif 8. Faham tak? Are you lost? Okay tak?
Betul.
Kenapa tiba-tiba meriah? Suara you. Macam ada orang cucuk apa you punya apa pinggang. So bunyi suara you. Ada orang cucuk you ke? I takut lah yang baju orange tu kot. Okay.
Tak ada.
Ke Haikal yang cucuk you ke baju orange tu? Okay, never mind. Okay. Sebab you punya suara tu macam ada orang macam usik you. Wah, macam tu kan. Okay, tak apa. Okay, so VA kita dah eliminate. Kita jadikan dia dalam sebutan VB and VB kita ada value. Okay, next adalah apa lagi? Apa lagi kita boleh eliminate? Sekarang ni kita nak apa? Soalannya kita nak apa? Kita nak ni kan? Delta SB, betul tak?
Betul.
So kan kita boleh jadikan delta SA dalam sebutan delta SB. Macam mana? 4 SA, 4 pula. SA sama dengan 4 SB. So SA sama dengan?
Negatif 4 SB.
So maksudnya kalau you masukkan ni dalam ni, formula ni, apa jadi? Kat SA. SA akan jadi?
SB 4. Negatif
Negatif
4 SB.
4 delta SB. So nanti semua dalam sebutan SB. So you boleh dapatkan SB, betul tak? Okay, so tolong dapatkan ISB. So sebenarnya equation ni jadi 81.1 negatif 4 delta SB plus 981 delta SB equals to berapa? 5 VA berapa tadi? Negatif 8. Jangan lupa square. Lepas tu campur ni berapa? 4 kali 200 kan? Betul tak?
Betul.
So tolong dapatkan apa tu delta SB. Masuk. Tolong dapatkan apa tu delta SB.
0.883.
Betul. 0.883. Okey, unit dia meter lah. You dapat positif ke negatif? Positif kan?
Positif.
Ya, positif.
So positif maksudnya ke bawah lah. Okay. Alright. So itu adalah satu example on yang ada. Tu ambil kunci tu. Tu kunci kereta. Sana. Okay. Alright. So basically you dah buat banyak examples due to workforce, due to variable force, due to constant force, due to weight. Ada lagi satu example tapi I nak bring forward example tu dekat kelas minggu depan. Kita ada kelas lagi minggu depan? Ke tak ada?
Minggu depan cuti Miss Sam.
Okay, tapi kita ada lagi satu minggu depan kan?
Yes.
Okay. So, untuk next week, bukan next week, week 7
Yes.
Week 7.
Okay. Untuk week 7, kita akan buat satu example on work energy. Kita akan buat satu example on work energy due to spring force. And then kita akan continue dengan topik chapter 3. Topik chapter 3 ni adalah on kinematics of rigid body sebab you punya test masuk topik ni. Okay, sebab you lepas tu week apa 8 you akan ada apa? Test apa 1 which is 20%, betul tak?
Yes, betul.
Okay. So kita kena habiskan ni masa week 7, 3 jam tu. Understand? Tapi masa week 6 hari tu, masa week 6 yang masa yang week 6 yang hujan lebat tu, yang rumah saya blackout tu, you dah tengok recorded video you dah tengok kan recorded video tu kan, tapi you tengok yang part 1. Ada satu lagi recorded video part 2 you belum tengok lagi.
Dia dah post
Dah. Part 1 ni kalau you ingat apa dalam recorded video tu, saya ajar Newton second law, betul tak?
Betul.
Tapi saya ajar apa? Saya ajar rectangular coordinate, and then yang non-rectangular saya ajar apa? Saya ajar yang normal and tangential saja, betul tak?
Betul.
Tapi for part 2, Newton second law, ada lagi satu which is radial and transverse. So I bagi you chance sebab sekarang ni dah pukul 5.25. Saya takut terlalu lama. You can watch the recorded video, salin and understand, and then tanya saya apa you tak faham, and then saya akan randomly pilih lagi sekali dan tanya you all untuk tunjuk nota tu, ataupun you nak buat kelas sekarang.
Okay, kelas assemble.
Tengok recorded.
Tengok recorded. Okay, you understand ke untuk tengok recorded macam mana? Faham kan? You boleh follow tak? Okay, kalau you tak boleh follow, boleh tak you tanya saya? Apa
Boleh.
you tak faham? Okay. So nanti saya akan randomly pilih juga siapa yang saya nak tanya, nak tengok you all punya nota, dan mungkin saya tanya soalan kot, nak tambahkan nak check pemahaman. Okay, so siapa yang tak faham tu ni, nanti saya share recorded video tu yang mana satu yang ada radial and transverse tu. Dia sama je, dia guna Newton second law, tapi soalan dia radial and transverse. Itu je. Okay, so boleh tak? Okay, and then after week 8, after test tu, maksudnya week 9,
Nice.
ni Dr. Iliani lah akan replace lah, Dr. Iliani lah. Okay, another doctor lah. Okay, boleh? Okay, and tapi saya punya recorded video untuk kelas lain masih ada. So kalau you perlukan, you boleh tengok jugalah. Okay, itu pun kalau miss me gitu. Tak ada miss kan. Goodbye kan. Okay, faham tak? Ada apa-apa soalan nak tanya?
Tak ada, madam.
So semua okay? So boleh tak you isi attendance hari ni dalam Everms? Lepas tu saya nak check. And then lepas you dah lepas you dah abaikan dah isi attendance tu, saya nak you baru you boleh leave lah. Kalau ada soalan, you boleh tanya soalan. Ada soalan tak?
Ada.
Okay, semua okay ke? Putri okay?
Okay.
Weh, yang Putri usik pinggang you. Okay, saya stop recording hari ni. Nanti saya share.